Hey everyone, have you ever just looked around at, well, everything and wondered what it's actually made of? I mean, really deep down? Well, today we are going on a wild adventure to uncover that secret. We're going to follow the journey of one single, tiny particle as it experiences the world in some incredible ways. Let's dive in.
So, to get us started, I've got a little riddle for you. Picture a massive, solid iceberg. Got it? Okay. Now picture a flowing, rushing river. And finally, think of a soft, fluffy cloud floating way up in the sky. I mean, they couldn't be more different, could they? But believe it or not, they all share one huge, fundamental secret.
And that's it, right there. The big secret is that they're all made of the exact same stuff, water. It's just arranged in different ways. On a level you can't even see, they're all just huge collections of these tiny, constantly moving particles. And today, we're going to pick just one of those little guys and follow its story.
So you can think of our particle as having three main places it can live, three different neighborhoods. Scientists, of course, call them states of matter, but each one has its own rules, its own unique vibe. Let's go pay a visit to each of our particle's three homes.
Okay, first stop, the solid state. Let's imagine our particle is now frozen inside an ice cube. It is packed in there, shoulder to shoulder with all its neighbors, locked into this perfect, rigid grid. There's no room to move around, no going for a stroll. All it can do is just kind of vibrate in place. It's super stable, really strong, and it holds its shape no matter what.
But what happens when we add a little bit of heat? Well, everything changes. Our particle gets a jolt of energy, enough to break free and move into a brand new home, the liquid state. Now it's in a glass of water, and things are way more relaxed. The particles are still buddies, they're close, but they're not locked down. They can slip and slide and flow right past each other, taking the shape of whatever glass or bowl they're in. Freedom!
And for the final home, our particle achieves total, absolute freedom. Welcome to the gas state. As steam rising up, our particle is just buzzing with energy. It's zipping around like crazy, bouncing off everything in sight. And look at all that space. The particles are super far apart now. A gas doesn't have a shape at all. It'll just spread out and fill every nook and cranny of whatever room it's in.
Okay, so we've met the three homes, solid, liquid, and gas. But how does our particle actually move from one to the other? It's not magic. The secret ingredient here is energy. That's it. Usually we're talking about heat. You see, adding energy gets the particles all excited and moving around, while taking energy away calms them right down. Let's watch this transformation in action. So our journey begins with melting. Our little particle is just chilling in its ice crystal, vibrating. But then it starts to absorb heat. So it vibrates a little faster and faster and faster until pop. It literally breaks the bonds holding it in place. It's not locked in anymore. It's now free to tumble and slide around with its neighbors as a liquid.
You know exactly what this looks like. Just picture a perfect scoop of your favorite ice cream on a super hot day. As the sun beats down, it's pumping energy into those particles and they break free, turning that solid scoop into a delicious, gooey puddle right in your bowl. That's melting.
So what happens if we pump in even more energy? Well, that's when we get evaporation. Back in the liquid, all the particles are moving, but some are moving way faster than others. And if our particle gets a big enough kick of energy, it can literally launch itself right off the surface of the water and fly off into the air. It just escaped. It's a gas now. You've seen this a million times. After a rainstorm, there's a big puddle on the sidewalk. But when the sun comes out, it warms the water, giving those particles the energy they need to escape, one by one, into the air. And before you know it, the puddle is just gone. That's our particle continuing its epic journey.
All right, what goes up must come down. So let's bring our particle back to Earth. Condensation is just evaporation in reverse. Our particle is zipping around as a gas, but then it starts to cool down, to lose its energy. It slows down, stops bouncing around so frantically, and starts to get drawn back toward its buddies, clumping together to form a tiny liquid droplet. You know this one too. You take a nice hot shower, and the bathroom fills with steam. That's a gas. But when our little particle, flying free in that steam, hits the cold surface of the mirror, it loses its energy in a flash. It condenses back into a liquid, creating all those tiny water droplets that fog up the glass.
And for the final leg of the journey home, we have freezing. As our particle, now in a liquid, gets colder and colder, it starts to move slower and slower until it just doesn't have enough energy left to slide around anymore. It finds a spot, settles in with its neighbors, and locks right back into that tight, organized, vibrating crystal structure of a solid.
This is probably the one transformation we actually control all the time. When you fill an ice cube tray with water and pop it in the freezer, you are literally the one removing the energy, forcing those particles to slow way down and lock into place. You're completing the cycle.
And there you have it, the whole round trip. Melting and evaporation on the way up, powered by adding energy, and condensation and freezing on the way back down, by taking it away. Our particle has been through it all. It's a pretty incredible journey, right?
Now, this isn't just some abstract story about an imaginary particle. This cycle is what makes our world work. This journey, from solid to liquid to gas and back again, is happening constantly in millions and millions of ways all around you right this second.
So here's your new mission. Become a matter detective. That solid ice in your drink is actively melting into a liquid. The liquid water in your kettle is evaporating into a gas. The very air you're breathing is a gas. Once you start really looking for it, you'll see the secret life of matter absolutely everywhere. So we've followed our particle through its three main homes: solid, liquid, and gas. These are the states of matter we see every single day. But that brings up one last, really interesting question. Are these the only homes a particle can have? Or could there be other, more extreme, more bizarre states of matter out there, just waiting for us to discover? Well, that sounds like a secret for another day.